Swayam Prabha. Digital India. Educated India.
So, in the previous session, we looked at the output decision of a perfectly competitive firm. What we learnt was that in the short run case where capital is fixed, a firm, a perfectly competitive firm chooses its output decision Q star based on the rule price equals marginal cost. But we learnt that we need to be a little bit careful when we use this rule. This is applicable only when the price is greater than the minimum average variable cost. So, if we wanted to characterize the entire sort of depiction of the supply curve of a perfectly competitive firm, we would know that if the price P star was less than the minimum average variable cost, then the perfectly competitive firm would not produce, and this would be equal to the shutdown condition, right. So, where I do not produce at all, the firm does not produce at all, and its profit would simply be equal to minus F c, which is the fixed cost that it would incur. For a price which is between the minimum average variable cost and the minimum average cost, right. So, when the price is greater than the minimum average variable cost, the firm is making enough total revenue to pay for its variable inputs. So, in that condition, the firm will produce some positive quantity of output, and the amount of output that it produces is based on the rule price equals marginal cost. So, we compare the price with the marginal cost to figure out this output Q, which is greater than 0, but the profit that it gets is going to be negative. Okay. So, this was the case wherein we looked at an example in the last discussion, wherein the price was 10 rupees per unit. It was between the minimum average variable cost and the minimum average cost. And finally, when the price P star is greater than the minimum average cost, then obviously the firm is always going to produce and its profit also is going to be positive, right. So, this is a case where the firm is making enough total revenue, not only covering its variable cost, but also pays for its fixed inputs. In other case, the economic profit is going to be positive. So, if we put together these things and look at the supply curve of a perfectly competitive firm, so what we have is the following. So, if we have rupees per unit on the y axis. So, let us say we have an average variable cost curve, which is the U shaped curve. This is the average variable cost curve, and if we take a marginal cost curve, which looks like this, let us say this is the marginal cost curve. Now, we know that the minimum average variable cost, corresponds to the shutdown price. So, for any price which is less than the minimum average variable cost, the firm is not interested in producing anything. So, the quantity supplied is going to be 0. So, if I capture this in a graph which is close to this, so let us take quantity here, let us take rupees per unit on the y axis. So, let me just call this point to be the minimum average variable cost. So, for any price less than the minimum average variable cost, the quantity which is going to be sold by this firm is going to be 0. At a price equal to the minimum average variable cost, the firm is indifferent between producing and not producing. So, if it does not produce, it is going to sell 0 units. If it produces, it is going to produce whatever this particular quantity is. And for any price which is larger than the minimum average variable cost. So, for any price which is larger than the minimum average variable cost, the firm is always going to be producing some positive quantity of output. So, for any of these prices, what the firm does is it reads out what quantity it wants to produce by comparing the price with its marginal cost. So, essentially we have these sequence of quantities which can be read out. So, that is essentially saying that if we pull out this portion of the marginal cost curve, above the minimum average variable cost, we would get so this portion of the marginal cost curve, right, which is corresponding to the portion above the minimum average variable cost, we would get the entire supply curve of a perfectly competitive firm. So, to complete the discussion, the supply curve of a perfectly competitive firm is the upward sloping portion of the marginal cost curve above the shutdown point. Above the shutdown price. So, if I have different firms, I could get the supply curve of each one of those firms, given that each one of those firms might have different marginal cost curves, but we would have a sequence of such supply curves, and to get the market supply curve we would aggregate these individual market supply curves. Okay. So, this is the discussion, sort of a brief overview of the supply curve of a perfectly competitive firm. Let us move on and talk about the topic of discussion today, which is monopoly and its regulation. Now, the monopoly is the other extreme of a perfectly competitive market. Mono means single. So, a monopolist is the only firm in the market producing a good for which there are no close substitutes. So, what we want to understand is, we want to understand the pricing decisions of a monopolist. Right. So, since it is the only firm in the market, it will have the ability to set prices. So, it is no longer going to be a price taker, and then we will ask, well, if it has significant power to set prices above marginal cost, what is the inefficiency that the monopolist is going to generate, and what can be done to reduce or eliminate this inefficiency. So, if we first look at the pricing decisions of a monopolist, so if I take Q and the price, notice that because it is the only firm in the market, the monopolist essentially faces the entire market demand curve, which is D. So, the entire market demand curve is for the monopolist. Now, a monopolist is going to set prices. So, it is not going to take the price as given. So, this question of given price, what is the quantity supplied, is no longer relevant. So, a monopolist will not have a supply curve, instead what it will have will be a marginal cost curve. Right. So, we will use the word marginal cost curve for the monopolist, because the fact that it is going to set prices rules out this notion that given the price, what is the quantity supplied, that is no longer valid. So, if I look at the demand curve, we can figure out what the marginal revenue curve is. This would be the marginal revenue curve. Right. So, if the inverse demand curve is linear, then the marginal revenue curve will have the same intercept and will be twice as steep. So, in other words, if my inverse demand curve is P equals A minus B times Q, my marginal revenue curve will have the same intercept, but will be twice as steep. So, this is the marginal revenue curve. Now, the monopolist will choose to produce QM units, where QM is its profit maximizing output level, based on the condition marginal revenue equals marginal cost. So, the monopolist will choose to produce QM units and will charge a price PM, which is given here, right. So, the pricing decisions is to first set its marginal revenue to equal its marginal cost, figure out what quantity it wants to sell, and thereafter find out what is the price at which the monopolist is going to be able to sell those QM units. Now, if I put some notations, let us call this A, let us call this B, let us call this point C, D and E, what we get is that the monopolist is going to earn a surplus, which is given by the area PM, B, D and E. So, if I look at the if I look at the total surplus generated under the monopoly. So, let us start with the consumer surplus. So, the consumer surplus is the gain to the consumer. So, the consumers are buying QM units, they are paying a price which is equal to PM, right. So, the consumer surplus is the area A, B, PM, that is the consumer surplus. So, for every point on the demand curve tells us what is the willingness to pay for each of those units. The consumer is paying PM for that unit. So, that gap is the gain to the consumer from that particular unit. So, this is the consumer surplus. The producer surplus on the other hand, the surplus that goes to the monopolist is, so the monopolist is receiving PM units for every one of its units between 0 and QM, right. The marginal cost curve is known to us. So, the area under the marginal cost curve is going to tell us what the cost is going to be. So, the producer surplus is PM, B, D and E. So, this turns out to be the producer surplus, which then implies that the total surplus when we have a monopoly producing is the area A, B, D and E. So, the area A, B, D and E is the total surplus that a monopoly market is going to generate. Now, if you compare it with the total surplus that would have been generated by a perfectly competitive market. So, consider a setup where we have the same demand curve D, but now the equivalent market supply curve would be S, right. So, let us say this is the supply curve that would exist in the competitive market. The way to see the way to derive the S would be, so I have the marginal cost curves for each one of those firms. If I were to aggregate those marginal cost curves, I would get the supply curve for a perfectly competitive firm. And we would know that the market clearing price P star would be that price P star where the demand curve and the supply curve intersect. So, the market clearing price P star would be here and the quantity would be Q star. So, in a perfectly competitive market, so if I look at perfectly competitive market, the consumer surplus, let me call it as CS star, would be the consumers are buying Q star units, they are paying a price P star for every one of those units. So, the consumer surplus is the area A, C, P star, that would be the consumer surplus. The producers, so producer surplus P S star on the other hand would be there, the producers are receiving P star for each one of those units that they are selling. So, the producer surplus is the area P star, C and E, which then implies that the total surplus under a perfectly competitive market is the area A, C and E. So, now if you compare the total surplus that a monopoly generates with the total surplus that exists under a perfectly competitive market, you would know that a monopolist is now leading to a deadweight loss. So, the deadweight loss, and we will see what is the source of the deadweight loss in just a minute. So, the deadweight loss essentially is the total surplus under a monopoly market minus the total surplus that a monopoly market would generate, and this is the area given by the triangle B, C and D. So, this area would be the deadweight loss, this would be the deadweight loss. Now, the source of the deadweight loss, so the source of the deadweight loss are these Q star minus QM units that are no longer being traded, right. So, if you look at the Q star minus QM units which are not being traded under a monopoly, and the reason why they are not being traded under a monopoly is because the marginal revenue for each one of those units is lower than the marginal cost. So, the monopolist is stopping at the level QM, because for the QMth unit the marginal revenue just becomes equal to marginal cost. For units between Q star and QM, the marginal revenue is less than the marginal cost, which is why those units are not being traded, because the marginal revenue becomes less than the marginal cost. However, for every one of those units, notice that the willingness to pay of the consumer, which is some point on this stretch BC for some particular unit. So, if I take this unit, the willingness to pay would be somewhere here, that would be greater than the marginal cost of producing those units. So, society would have benefited had that unit been traded. So, for that particular unit the willingness to pay was greater than the marginal cost. So, society would have benefited, but for each one of those units but for each one of those units the consumer's willingness to pay is greater than the marginal cost of producing those units. Right. For each one of those units the willingness to pay is greater than the marginal cost of producing that unit, which means there would have been a gain from trading that unit. But because the monopolist finds that the marginal revenue is less than the marginal cost, that unit is no longer being traded. So, these gains are no longer being captured. So, this gain essentially is lost. Because it is lost, it is part of the deadweight loss. So, if we were to aggregate all those gains for units between QM and Q star, we would be capturing gains which is equivalent to the area BCD, and because these gains are not being captured, it is part of the deadweight loss. So, the deadweight loss, which is the triangle BCD, can be interpreted as the lost surplus which arises due to gains that could have been captured, but are not being captured, right. Why? Because the monopolist is not interested in trading those units. So, now given that the monopolist is generating a total surplus which is less than the total surplus that would generate under a perfectly competitive market, is there a room for some regulator to intervene and improve on the outcome? So, let us see how a monopolist can be how we can regulate the monopolist and improve on the total surplus that is being generated. Okay. And the regulation that we will talk about is a ceiling price. So, we will look at a ceiling price to regulate a monopolist. So, if I look at first the baseline monopoly condition, this is the marginal revenue curve, let us say this is my marginal cost curve of the monopolist, and we know that the monopoly outcome is obtained by comparing the marginal revenue which is equal to marginal cost, and the monopoly price is P. This is the monopoly price. Now, the equivalent competitive market condition would be a competitive output of Q star and a competitive price which is P star. So, now if I set a ceiling price, recall a ceiling price is the maximum legal price at which trade takes place, right. So, this is the maximum legal price at which trade takes place. So, a valid ceiling price when you have a monopoly, so the monopoly price already is PM. So, a valid ceiling price is any price less than PM. So, a valid ceiling price is, so let us call the ceiling price to be PC, is less than PM. Suppose the ceiling price is set, at a level which is equal to P star, which is the competitive price, right. So, for completeness this would be the equivalent supply curve for the competitive market, right. So, suppose I set a ceiling price which is equal to P star. Now, because this is the maximum legal price at which trade takes place, essentially it implies that any price greater than P star cannot be charged. So, I set a ceiling price which is equal to P star. So, essentially for the monopolist this portion of the demand curve suddenly becomes redundant, right. So, I cannot charge a price greater than P star. The monopolist of course is always free to charge any price lower than P star. So, this portion of the demand curve continues to exist. So, the demand curve is altered as follows, right. So, the one in red is your new demand curve. Now, because the demand curve is altered, the marginal revenue curve also gets altered. So, the new marginal revenue curve will be tracing out this flat portion of the demand curve up to Q star, and thereafter it will jump and follow the old marginal revenue curve, right. So, the reason being that this top portion of the demand curve is sort of non-existent now, because the monopolist cannot, the consumers are there, but the monopolist cannot charge a price there. So, the demand curve is flat or elastic in this portion. So, the MR also is flat, and from this portion onwards the demand curve is what it was earlier. So, the marginal revenue curve also traces the older marginal revenue curve. So, when the monopolist is comparing the marginal revenue with the marginal cost, so let us call the new marginal revenue to be MR prime, right. So, the new marginal revenue to be MR prime. So, when the monopolist is setting the marginal revenue to equal the marginal cost, the monopolist is going to compare the new marginal revenue with the marginal cost and will end up producing. So, MR prime equals marginal cost leads us to Q star units being produced. And notice that Q star is exactly the quantity that a competitive market would have produced, right. So, by setting the new marginal revenue to equal the marginal cost, the monopolist is now able to produce Q star. Now, another way of thinking of this is that, recall, the source of the deadweight loss are the Q star minus QM units which are not being traded, right. So, our objective, so these were the units for which the deadweight loss was present. So, if we wanted to eliminate the deadweight loss, our target should have been to push the QM as close as possible to Q star, and the only way that is going to happen is if we have some regulation which forces the monopolist to lower the price. The monopolist left to himself would have chosen the price PM. So, we introduce a ceiling price. The ceiling price is the maximum legal price which brings the price down to P star, and at that price P star, the quantity that the monopolist is actually going to choose is going to be Q star. So, now notice that if we were to write down what the consumer surplus and the producer surplus were. So, the consumer surplus with the ceiling price, right, with the regulation, the consumer surplus would be the area. So, consumers are buying Q star units, they are paying a price P star. So, the consumer surplus would be this area A C P star, which is exactly the consumer surplus that would have come up when the competitive market was there. And the producer surplus now with the regulation, the producer, which is the monopolist, is getting a price P star, right. The monopolist cannot charge a price more than P star. The monopolist sells Q star units. So, the producer surplus is P star, C and E, which is exactly the producer surplus that we were generating when the market was perfectly competitive, which tells us that the total surplus is equal to the area A, C and E, which is exactly equal to what we had under the perfectly competitive condition. So, by introducing a ceiling price which is exactly equal to the competitive price, we are able to eliminate the entire deadweight loss. Okay. Now, well, is this ceiling price valid for any monopolist? Let us dig a little bit deeper here. Let us look at a particular monopoly structure which is called a natural monopoly. So, let us first define what a natural monopoly is. So, a natural monopoly, if the total cost a single firm would incur in producing the output is lower than the combined total cost that two or more firms would incur. So, a market structure would be a natural monopoly if the total cost a single firm would incur is lower than the combined total cost that two or more firms would incur. Okay. So, what does this mean? Let us draw a picture and see whether we can make sense of it. Right. So, consider a case where you have quantity and price, where we have a demand curve D, right. And let us take a particular form of cost structure. So, where the total cost, let us say, is F plus C times Q. This would imply that the marginal cost which is the change in cost resulting from a change in output dC dQ is a constant C. So, the marginal cost would be a constant C, this would be the marginal cost, and the average cost would essentially be F over Q plus C. So, as Q goes to infinity, the average cost would be C. So, my average cost, let us say, is something like this. The average cost would be something like this. It gets closer and closer to the marginal cost as Q goes to infinity. Now, what would a monopolist do? A monopolist, as before, would compare its marginal revenue with its marginal cost and choose to produce QM units and would charge a price which is equal to PM. Notice that the average cost of producing each one of these QM units is somewhere here. Right. Now, because PM is greater than the average cost of producing those QM units, it essentially implies that the profit of the monopolist is strictly greater than 0. Now, because the profit is positive, let us say a new firm wants to enter the industry, right. So, a second firm enters and the two firms for some reason decide to split the output, right. So, one more firm enters and the total output is split. For simplicity, let us say that the total output is split in half, need not be, the argument is valid for any sort of such split, but let us for a moment say that the total output is split in half. This then essentially implies that each firm is producing QM divided by 2 units, right. Now, the average cost of producing each one of those QM upon 2 units is average cost QM by 2, this is the average cost. But because the total output produced is still QM, the price continues to be PM. So, now we have a peculiar situation where the price PM is the price is still PM, but the average cost is AC QM by 2. So, PM is less than the average cost that the firm would incur, right. So, the firm cannot, so two firms cannot profitably coexist. So, the main message here is that you have one firm which can profitably exist and produce some output at a price PM, produces QM units, but the moment one more firm enters, the two firms cannot profitably coexist, right. So, this is what we meant when we said that the market structure is such that if the total cost a single firm would incur in producing the output is lower than the combined total cost that two or more firms would incur. Okay. Now, we looked at a ceiling price to regulate a monopolist, right, wherein we said a ceiling price which is equal to P star completely gets rid of the deadweight loss, right. So, the deadweight loss essentially would be 0. So, here the deadweight loss was essentially 0. Now, can we impose a similar kind of regulation for a natural monopoly, which means can an average can a price which is the ceiling price regulation be used to regulate a natural monopolist. So, let us check. Ceiling price imposed on a natural monopolist. Okay. So, let us again quickly draw the demand curve and the monopoly outputs. So, this is my demand curve, this is the marginal cost curve, and we have an average cost curve which is this. So, similar kind of structure that we had earlier. See, the current monopoly choice is by setting the marginal revenue equals to the marginal cost. So, this is QM, and we will simply trace out what the PM is. The equivalent competitive output would be where the demand curve and the equivalent supply curve in the competitive market would intersect, that would be at Q star. So, the competitive output would be Q star and the competitive price would be equal to P star, right. So, the competitive, so if the market was perfectly competitive, the demand curve and the supply curve would intersect at a quantity Q star leading to a price which is equal to P star. Now, suppose the government imposes a ceiling price which is PC, and this ceiling price is exactly equal to the competitive price P star. So, in other words, now by law the monopolist cannot charge a price which is greater than P star, right. So, essentially this portion of the demand curve no longer exists for the natural monopolist, right. The consumers are there, mind it, the consumers are there, but the monopolist cannot choose a price, the natural monopolist cannot choose a price there. So, if that portion of the demand curve is chopped off, the demand curve essentially becomes this flat portion until Q star, and then it follows the old demand curve. Because the demand curve has changed, the marginal revenue curve also would now change. The marginal revenue curve would follow the flat portion of the demand curve until this point, and thereafter for the portion of the demand curve which was present in the previous case, the marginal revenue curve essentially would coincide with the earlier marginal revenue curve. So, the marginal revenue and the marginal cost are overlapping across a bunch of Qs. The point that is of interest to us is this Q star. So, by setting a ceiling price which is equal to the competitive price P star, the regulator has forced the monopolist now to produce Q star units. But is that, but will this work? Let us think. So, for each one of these Q star units, notice the average cost of producing those units is somewhere here. So, the average cost of producing these Q star units is somewhere here. So, this average cost of producing the Q star units is greater than the ceiling price which is equal to P star, which means the profit of the monopolist is going to be negative and the monopolist will exit the market. So, a ceiling price which is equal to the competitive price does not work. So, PC equal to P star does not work. Right. So, the reason this is important is that when we apply regulations like ceiling price, it is extremely important to know what is the exact market structure in which the firm is operating. While it worked for a monopolist, it does not work for a natural monopolist. One more point to note here which I missed mentioning here is that in a competitive market, if you impose a ceiling price, right. So, the competitive price is P star, and in a competitive market if we wanted to impose a ceiling price, that would have been lower than P star. That ceiling price would actually lead to a deadweight loss, but a ceiling price which is imposed on a monopoly market actually gets rid of the deadweight loss. The ceiling price imposed on equal to the competitive price imposed on a natural monopoly does not work, right. So, if that does not work, what should we do? So, how should a natural monopolist be regulated? We use what is called an average cost pricing. An average cost pricing. So, if we look at the demand curve again, and the marginal revenue curve, this is the marginal cost as before, and let us say that the average cost is here. this is the average cost curve, right. So, the average cost pricing rule is that we set the ceiling price which is PC to equal the average cost, right, but which average cost, which is where the average cost curve cuts the demand curve. So, let us say the average cost is cutting the demand curve at some quantity which is, let us say, q hat. So, set the ceiling price PC equal to the average cost, where the average cost is cutting the average cost curve is cutting the demand curve. Now, let us see whether this will work. So, essentially we are keeping a ceiling price here. So, this is the PC which is equal to AC of q hat. So, essentially now we are altering the demand curve. The demand curve for the monopolist now is this flat portion and then this portion. This would be the demand curve for the monopolist. Well, if the demand curve is altered, the marginal revenue curve also will be altered. The new marginal revenue curve is going to be perfectly flat until this portion, and then it will follow the old marginal revenue curve. So, this would be the new marginal revenue curve. So, when the monopolist sets the new marginal revenue to equal the marginal cost, when the monopolist sets the new marginal revenue to equal the marginal cost, notice the monopolist ends up producing q hat units, right. So, the monopolist will produce q hat units and will sell these q hat units at a price which is equal to PC. Now, the competitive output is q star, which is here. So, while our objective was to push the monopoly output towards the competitive output, where is the monopoly output? The monopoly output is qm, which is here. So, our objective was to push the monopoly output towards q star. We tried doing it with a ceiling price, that did not work. So, we now impose an average cost pricing rule, a ceiling price equal to the average cost, wherein we have brought it closer to q star, but we have not been able to make it exactly equal to q star. So, this regulation will be better than the status quo monopoly condition, but it will not eliminate the deadweight loss completely, Some amount of deadweight loss will still be there, and that deadweight loss is going to be this area. This deadweight loss will still exist. The reason being that with q hat units being sold by the firm, the consumers are paying a price PC. So, the consumer surplus essentially is the area given by A, B and PC. So, the consumers are buying q hat units and are paying a price PC, and the monopolists, whereas under the perfectly competitive condition, the consumer surplus was the area A, let us call this to be D, A, D and C. The consumers were buying q star units and were buying and were paying a price which is equal to C, and the producer surplus under the competitive condition would not be there. So, the entire surplus goes to the consumer. So, the total surplus under the competitive condition would have been A, D and C, that would have been the total surplus, whereas the producer surplus is this area P, C, B, E and C. So, the total surplus under the average cost pricing rule is the area A, B, E and C, which means that there is a deadweight loss, equal to the area B, D, E. So, the deadweight loss continues to be there, but it is still better than the status quo monopoly, which would have generated a much larger deadweight loss. So, the deadweight loss under the status quo monopoly would have been a much larger triangular area. Okay. So, while a ceiling price equal to the competitive price does not work, a ceiling price equal to the average cost, where the average cost curve cuts the demand curve, will work. So, we looked at the pricing decisions of a monopoly. We looked at what is a natural monopoly, how to regulate the natural monopoly. What we want to do next is we want to consider one factor or one setting that might limit the ability of a firm to exercise market power. So, we looked at perfect competition earlier, we looked at monopolies a little while earlier. We want to construct an analytical framework that has flavors of both perfect competition as well as monopoly behavior. So, we want to, of a dominant firm, a dominant firm with a competitive fringe, and we will define it in just a moment. So, let us first define what a dominant firm. So, if one firm is a price setter, and faces other smaller price taking firms, it is called a dominant firm. So, if there is one firm which is a price setter and faces other smaller price taking firms, then this firm is going to be called a dominant firm. The smaller price taking firms, are called the fringe firms. They are called the fringe firms, right. Individually, each one of these fringe firms is very, very small. Individually, each one of these fringe firms is small, which means it does not have enough capacity to serve the entire market, but collectively their market share is substantially large. So, why is it that some firm could be a dominant firm? Possibly this firm has been in this industry for a long time, it has attained a reputation. The other reason why a firm could be a dominant firm is that it has a significant cost advantage, right. So, it could possibly be more efficient than other firms. So, some of these factors or it could even be some government policies might favor some particular firm which has allowed it to be a dominant firm. So, there could be multiple reasons why this firm is a dominant firm. What we want to do is we want to set up an analytical framework for understanding how the price and market shares are going to be determined in the framework where we have one firm which is a price setter and it faces competition from other price taking firms. Okay. So, let us first list some assumptions of this model. So, the first assumption is that there is going to be one firm, which is substantially larger. There is one firm which is substantially larger than the other firms. Then all firms other than the dominant firm are price takers. And so, the dominant firm is going to set the price and each one of those fringe firms take that price as given and will then choose to produce some quantity of output. The number of fringe firms is fixed at n. Let us say is equal to n. We will see what happens when there is entry into the model and n can change. The dominant firm knows the market demand, which is let us say given by Qm as a function of P. So, let us say this is the market demand. The dominant firm also has enough information to know what is the supply curve, total supply curve of the fringe firm. So, dominant firm also knows the supply of the fringe. And let us call the supply of the fringe firms to be QFP. So, essentially the first three assumptions the first three assumptions basically tell us that there are n fringe firms and there is one dominant firm, right. So, in other words, there is a dominant firm which is facing competition from fringe firms, the number of which is n. Assumptions 4 and 5 essentially are telling us that the dominant firm has enough information to figure out how to choose its optimal price in order to maximize profit, and that is what we are going to be studying now. So, we know the dominant firms, the market demand curve is QM and the supply of the fringe is QF. So, let us call the residual demand faced by the dominant firm to be QDP, right. So, QDP essentially is QMP minus QFP, right. So, whatever is the total market demand at any particular price, suppose the fringe is selling QFP, then whatever is remaining is the residual demand that the dominant firm is facing. The profit of the dominant firm, so let us just write it as phi t, is the price, total revenue minus total cost. So, price times the quantity that it is going to sell, which is P times QDP, minus the total cost. So, let us say that the total cost is just C of QDP, right. For particular cost functions we will be able to write it down properly, right. Now, so the firm is the dominant firm essentially is going to behave like a monopolist with respect to this residual demand curve. So, the idea is that at any particular price P, the dominant firm knows what the total quantity demanded is going to be. So, the dominant firm knows what the demand curve is QM. At any particular, at each of those prices, the dominant firm also knows how much the fringe will want to supply. It therefore figures out what the residual demand curve is, and then it will act as a monopolist with respect to the residual demand curve, act as a monopolist with respect to the residual demand, with respect to the residual demand, right. So, in other words, I could set the marginal revenue for the residual demand curve equal to the marginal cost, we will do that, or I could figure out what the optimal price is and thereafter figure out what the optimal quantity is. So, if I take the derivative with respect to price, essentially we have QD. So, I will suppress the P here, plus P times dQD dP minus the derivative of this term essentially is going to be dC dQD, I will also suppress whatever is inside the bracket, times dQD dP, right, and would set this to equal 0, right. So, the monopolist is either choosing the quantity and figuring out the price, or can figure out the price and therefore figure out what the quantity is from the demand curve, right. So, this is essentially, this gets simplified to QD plus P minus, this is the marginal cost, dC dQD of the dominant firm, times dQD dP equals 0. Now, let us think about what this means. So, essentially there are two terms here. So, when the dominant firm increases the price by, let us say, rupee 1, its profit goes up by the extra revenue that it earns on all the infra marginal units. So, this is the increase in profit from all the units, right. So, there are QD of those units, right. So, I increase the price by 1 rupee, the total revenue increases by the amount QD, right, because there are QD of those units. But then when I increase the price, the quantity drops. So, recall this is a negative number, right. So, this is negative. So, when the price increases, Q falls. So, so Q falls at the rate dq dp, and for every unit which is not sold, the firm suffers a loss equal to the margin on those units. So, this is the price cost margin, right, that I am going to be losing. So, essentially this term basically means that when I increase the price, I lose some units because the quantity has fallen, and the firm is going to lose the margin on all those units. So, there is a trade off for the firm. So, I get some increase in revenue, right. So, I increase in revenue. So, let us actually call this as increase in revenue instead of profit, that will be a better term, increase in revenue from all these units, and there would be a corresponding decrease on the other side. Okay. So, let us simplify this. So, essentially I have QD plus, so let us just rewrite it again, P minus dC dQd times dQd dP, which is equal to 0. And also notice that QD is essentially QM minus QF. I am suppressing the price terms here. So, dQd dP is essentially dQm dP minus dQf dP. So, if I replace that here, essentially we would have QD plus P minus dC dQd times dQm dP minus dQf dP, which is equal to 0, right. So, this is what we would get. Now, if I further simplify, so this term dQm dP is the reduction in market quantity demanded. This is the reduction in market quantity demanded, whereas dQf, which is a negative number. So, dQf dP is an increase in the fringe supply, This would be the increase in the fringe supply, and essentially we would now have, if I were to rewrite this, we would know that P minus, so we will call this as the marginal cost and save some space. So, dC dQ is essentially the marginal cost, right, is equal to minus of QD divided by this bracketed term, which is dQm dP minus dQf dP, this term right. Now, we also know that the Lerner index of market power, right. So, this is the Lerner index which measures the market power of a firm, is essentially P minus MC divided by the price. So, if I were to do that algebra here, I would again have a P here, right. So, the Lerner index would essentially be P minus MC by P. So, what we did was we computed the price minus marginal cost as minus QD divided by the second bracketed term, and the Lerner index essentially is P minus MC divided by P. So, that turned out to be this particular expression. Now, let us simplify this a little bit. So, essentially I have QD, so minus QD. So, let's simplify this further. So, let us say I have a QD, let me divide it by QM on both the numerator and the denominator, you will see why in just a moment, and let me take the minus sign inside here. So, I have a minus dQm dP minus dQm dP, and I have a P, and because I divided the numerator by Qm, I need to divide by Qm here. This minus and the second bracketed term makes it a plus. I have a dQf dP, and I have a P. So, since I want to have some measure of elasticity, let me put a QF here, then I can multiply with a QF there also, and as before I had a QM on top. So, we are doing an algebraic manipulation wherein we have divided both the numerator and the denominator by Qm, and we have Qd divided by Qm, and in the denominator we have minus dQm dP, P divided by Qm plus the second term. So, essentially LD, the Lerner index of market power for the dominant firm. So, look at the first term here, look at the term Qd divided by Qm. So, this is the market share, right, this is the share for the dominant firm. So, let us call this as SD, right. So, that is SD. On the denominator we have minus dQm dP times P divided by Qm. We know that the elasticity of market demand is the percentage change in quantity demanded resulting from a percentage change in price, which essentially is dQ dP times P by Q. It is just that we are doing it for the market demand. So, I have a Qm here, right. So, this is basically the price elasticity of market demand, plus I have a term which is this term, essentially which has a similar kind of interpretation, but now it is for the fringe firms and it talks about fringe supply. So, this is the elasticity of supply of the fringe firms. So, I will put it as EF, and the last term here QF divided by QM is the market share of the fringe firms, we will write it as times SF. Right. So, essentially we have the Lerner index of market power for the dominant firm being SD divided by the elasticity of market demand plus elasticity of the supply of the fringe firms times the market share of the fringe firms. So, few observations. So, the market demand of the dominant firm. So, if we make a few observations here, we can say that if epsilon is large, greater is epsilon, lower is the market power of the dominant firm, lower is the market power of the dominant firm. Well, a larger epsilon essentially means, when epsilon is larger, it essentially means that the price elasticity of demand is very high. Well, if the price elasticity of demand is very high, then the ability of a firm to charge a price significantly greater than the marginal cost gets reduced a lot, right. So, because greater will be the consumer's willingness to substitute for other products, right. So, that is one observation. The second observation is greater is EF, which is the elasticity of supply of the fringe firms, which is greater is the supply responsiveness of the fringe, again lower is the market power of the dominant firm. So, what this essentially means is that if the dominant firm, so attempts by the dominant firm to raise the price is less successful, greater the ability of the fringe firm to provide opportunities for supply substitution. So, essentially greater is epsilon essentially means that the fringe is able to provide substitution possibilities for the consumers. So, a dominant firm's power to charge a price significantly greater than the marginal cost gets reduced by the presence of the fringe firms. So, unlike a monopolist which would simply look at its marginal revenue and set it equal to marginal cost, the presence of the fringe makes it relatively less easier for the dominant firm to set the monopoly price. In the next session, we will look at a graphical representation of the dominant firm competitive fringe model, and we will see what happens when there is free entry. Thank you.